Hello guys, I have a little surprise for you. This is a Boeing 737-800 cargo airplane. She landed in Winnipeg last night from Montreal. This is a 20 years aircraft. She was built in Everett, USA. It was delivered to Miami International Airlines in 2004. Then in 2021, they changed it to the cargo airplane, and it was used for domestic flights in Canada. 7 cockpit with Captain Jeremy. Is going to explain a lot of stuff to you guys. Let's begin.
Sure. Hi, Amir. Thanks for coming in today. So why don't we start on a standard kind of flow pattern. But anyways, every pilot in front of them has this display here. You can see the same on the other side. It's called the primary flight display. It's got airspeed here, the aircraft attitude, which is pitch, nose up and down, and angle of bank. Aircraft altitude, which we would set, of course, with a current altimeter setting. So right there. This little needle here would show our vertical speed in thousands of feet per minute. We have a little backup compass rose down here. This little number that you see here is controlled by this knob. It's for setting minimums for any approach we would do. So for example, if it was set to 1100, we wouldn't fly below that for a certain approach. Then we have our nav display, it's called. We can put any number of things on that. It's pretty basic compared to a lot of newer airplanes. But we have our position, we have data there if we had a route. We can put airports, you can see CYWG. Waypoints will pop up if we needed to go find a certain waypoint. And of course, once we loaded a flight plan, it would show our flight plan on there. We can change our scale up to 640 miles. When we had our weather radar display, that would show up on here as well to tell us where the thunderstorms are to avoid. Moving on, the standard stuff, we have a landing gear lever. It's obviously down because we're on the ground. When we take off, we put it up, and then when we're finished our takeoff, we put it to the off position, which depressurizes the hydraulic system to the landing gear. That's our flap gauge. You can see the flaps are up now. We can put them all the way down to 40 degrees. This is called the auto brake. So rather than having to press the brake pedals with our own feet, on landing we can set 1, 2, 3 or max. And on takeoff, we put it to RTO, which is called rejected takeoff. So basically what that does is once we're on the ground on landing, it will brake the airplane for us. Our engine displays, N1, exhaust gas temperature, that's how hot the air is leaving the engine, and then all the different engine displays. So that's the first compressor turbine, the second compressor turbine, fuel flow, oil pressure, oil temperature, oil quantity. Every engine vibrates, so this tells us how much it vibrates, and if it gets too high, we would have to shut it down. There's a few different little engine gauges here, like start valves and oil pressures. Moving on to the center console, we have speed brakes. So there's speed brakes on the wings that will extend in flight if we need them to help slow the airplane, and they also extend automatically on landing to help put the airplane more firm on the ground to allow the brakes to work better. Our thrust levers for forward thrust and reverse thrust, which we would use on landing. Flap levers from 0 all the way to 40. We would set our parking brake there. When we start the engines, we have to use these two levers to put fuel into the engines. We also have all of our fire controls here, which I can test a number of ways. But you can see the light up when we do that. And that would tell us either one engine or the APU is on fire. Radios, transponder, the weather radar controls. This is all related to the new conversion for cargo operations, so that's all cargo smoke detection. Let's see what else. On the autopilot, the mode control panel, set our course here for instrument landing. Auto throttle turns on there so that we don't actually have to manipulate these. It's all done automatically. We can set our airspeed in here, our heading here, our altitude here. We can adjust vertical speed here. Then these VNAV and LNAV functions would be all based on what we entered in the flight management computer. The autopilot switches are here. I already kind of touched upon this stuff, but this basically controls all the information that we see on there. And moving to the overhead panel, every Boeing is pretty standard, but we always have fuel on the far left. Moving in, we always have electrical controls, hydraulic, there's some engine and anti-ice and probe heat up here. This is all related to pressurization and air conditioning. So if we have the engines running or the APU running, we can turn on these packs, which would help cool the airplane and the bleed airs and make sure that we're pressurized. And then it's all lights here. I think that's about everything. Or at least a very quick overview, which I hope you all enjoyed.
Thank you. Thank you very much.
No problem.
For the two. APU stands for Auxiliary Power Unit. When the aircraft doesn't have thrust from the engines, for example, if they have bird strikes and the engines are failing, the first thing that the pilot does is turning on the APU. Basically, APU is a turbine and it generates electricity, and the electricity will run the electronic equipment and hydraulics.
This is the Chrono Aviation Boeing 737-800 freighter. This is the cargo hold part of it for the upper deck. So right here, it'll show the different variants of positions we can put. Usually it's the alpha configuration. We also have the mic version as well, but we don't usually.
Let's make a comparison with 737 and A320. In 2010, Airbus introduced a new kind of aircraft for A320 family. It was A320neo. And the engine was fuel efficient and very powerful. So it would save a lot of money for the airlines. Right now in Canada, fuel jet is $2 per liter somehow. So in 2010, when Airbus introduced A320neo, airlines wanted to have them for the medium range destinations. What was the Boeing's reaction? They wanted a fast result. The fastest result, it was that we have 737. It's 50 years running. So what we can do with an engine that is fuel efficient and more powerful than Airbus. Guys, let's see inside the engine oil access. It's 36 meters from this tip to the other tip. The overall length of the aircraft is 40 meters. The cabin width is 3.6 meters. The wing area is 125 square meters. Let's go for the average cruise speed. The average cruise speed is 850 kilometers. And as you can see, the wings are carrying the weight of the fuel. Basically, when you see these are when they open these somehow box, and the fuel pump will go through there, and they will put fuel, jet fuel in it, and the most of the fuel is in the wings. 95% of the fuel is in the wings, and the maximum fuel capacity of this aircraft is 26,000 liters. The range of the aircraft is 5,000 kilometers, and its cargo capacity is 6,000 kilograms, 6 tons. And let's go to the engine. This engine is CFM56. It is a American built engine. It was partnership with Boeing and Rolls-Royce. The maximum thrust is 117 kilonewtons, and as I mentioned earlier, because the original size of the engine was too small, and because they had to have the limitation, the safety limitation to the ground, as the engine frame was getting bigger, the engineers thought that instead of making the engine circle, we can make this area different so we can have the safety length. Also, the engine is bigger, as you can see. This is also very efficient aircraft, mostly because the engines are new somehow. It's efficient, but the rival of this aircraft is Airbus A320, the classic Airbus A320. The next generation of this aircraft is 737 MAX. 737 MAX is a little bit different from this aircraft. Boeing wanted to put a more bigger engine because bigger engines means that you can have more air. More air means that you can have more thrust. So more thrust and more efficient engines can be useful for the airlines because they can save money for the fuel. So when they wanted to make the engine bigger, they had a limitation of the safety length to the ground. So they changed the height of the engine. They make it higher than the underneath of the nose. Underneath of the nose is the weather radar, and it's very essential to the aircraft because usually before the flight they give the pilots a print of the weather, but somehow the weather conditions change during the flight, so they use the weather radar on the aircraft for the sudden changes in the weather conditions. So underneath of the nose is the weather radar. Landing gear. This is the landing gear. This is the brake system. Also, let's go to the inside of the airplane. As you can see, there are a lot of pipes and high-tech stuff over here. Engine, the blades. The blades are made of aluminum, and you can see the Eagle signature in the center.